Okay guys, this is Mr. Gibson. I'm going to show you all how you can apply properties of logarithms. So first let's talk about what a logarithm is. We have an exponential expression here, or equation, that is some b base raised to the x equals some number a. Well, if you rearrange this with a function called a logarithm, you take the logarithm of that base b with the base b of this number a, and it will give you x. That's what a logarithm does. A logarithm, a lot like the properties of exponents, has similar properties, okay? So there's this additive property where if you want to expand a logarithm with a base b and two numbers m and n, they're times each other, it becomes two separate logarithms with the base b that are added together. So you have log base b m plus log base b n, okay? And then you can use it in the opposite direction. If you have two logarithms of the same base, that's important, they have to have the same base, then you can take the numbers that are being taken of the log and multiply them together into one log, okay? Similarly, so that really comes from the idea that when you multiply exponents together, you add their exponents. And when you multiply exponentials together, you add the exponents. Similarly, when you divide exponentials, you subtract their exponents. So similarly here, if you have two numbers divided by each other within a log of base b, then you can separate it into two logs that are being subtracted by each other. So log base b of m over n equals log base b of m minus log base b of n, okay? And then just like the additive property, you can contract that, combine it. If you have two logarithms of the same base again, they're subtracted by each other, you can combine it into one where the numbers that are being acted on by the log will be divided. The final property is called the power property. So just like with powers, you have a power raised to another power, you multiply those powers. Similarly here, if you have a power inside of your log, you can bring it out front and multiply that log by whatever that number is of the power. So this n basically just came out front. And similarly, you can just contract it by, if you have a number out in front of the log, you can put it inside the log as a power. Okay, so those are the three properties. Now let's look at a few examples. So here's an example where you're going to expand. Okay, so the first thing to notice is there's division here. X squared is being divided by y to the third. So we are going to expand it into two logs that are being subtracted. So log base 3 of x squared minus log base 3 of y to the third. These arrows here, if you notice, look, we've got powers, we've got exponents. So we can bring those to the front of these logs. So that's how you end up with 2. So this 2 comes out front, 2 log base 3 x minus this 3 comes out front, 3 times log base 3 of y. Okay, so that's expanded out. Okay, and we use two properties there, right? The subtraction and the power property. Here's a little more difficult one with expansion, and we're going to have to use a few other mathematical ideas that we've talked about this year. So the first one is, this is a square root. Well, a square root is an exponential, is a rational exponent of 1/2. So I just rewrote it like that. And the reason why I rewrote it like that is because, look, that's just a power to the 1/2, so I can bring the 1/2 out in front of this entire log, okay? The next thing is, look, these three numbers are being multiplied by each other. So that means I can write three separate logs of the same base, base 9, and add those all together. So log base 9 of 7 plus log base 9 of 5 plus log base 9 of 6, okay? And that's all multiplied by this 1/2 that we've already used the power property to bring out front, okay? The rest of this is I'm just doing a little bit of algebra. So I distribute the 1/2 in, and then I multiply 1 times all of these, 1 times all of these, 1 times all of these, just to get these nice looking log base 9 of 7 over 2 plus log base 9 of 5 over 2 plus log base 9 of 7 over 2, okay, just to make it look that way. All right. And of course I could combine all those together with a base of 2 as well. I can show you guys that real quick. So if I could, we have a common denominator here. So with the common denominator, I can write it out like this. Okay, so from this point on, this is just doing a little bit of algebra manipulation that we've learned in the past. Back to the front here, we're learning, we're using the power property, and then from this step to this step, we're just expanding it out with addition. All right, so similarly, we're going to contract now. So we're going to change the 1/3, or change the divided by 3 to times 1/3 for each one of these. Now I'm pointing, so instead of using the power property to bring a power out, I'm going to use the power property to bring a power in for each one of these. Again, something raised to the 1/3 rational exponent is just a radical of the cube roots. Cube roots right here. Look, they're all being added, so that means that we can combine them all together, contract them all into, and look, again, it's important, they all have the same base. So log base 6, multiply all these together. Well, they're all cube roots, so they all multiply together underneath a cube root, and you end up with that. Okay, that was some contraction. And then finally, this is a little easier contraction one. Again, we start out with these two logs being multiplied by something. So, you know, I'm taking the 6, making it into a power, taking the 36, making it into a power. We got subtraction here, so it'll become a division problem. Again, same base, that's important. Okay, so we're going to have the, and the order here matters as well, because we're taking the log base 6 of x to the 6 minus log base 8 of y to the 36. So subtraction, it's going to be this over this, okay? So we divide x to the 6 over y to the 36, and we're done. It's contracted, okay? Again, these are the properties. Look at the notes. Try to understand them. You can watch the videos again, and make sure you do the assignment that's assigned to this. Thanks.